Hi guys, in this video we'll see how to deal projectile on an incline. Okay, so for a projectile on an incline, just take the component of velocities, acceleration along and perpendicular to the incline. I have taken x-axis along the incline, so the y-axis will be perpendicular to the incline. These are obviously non-conventional x and y axis. Conventional x and y axis are horizontal and vertical. But as we are talking about the plane, so it is always better to take the components along and perpendicular to the incline to study the motion with respect to the plane. So let's say theta is the complete angle, alpha is this angle of incline, theta is the angle of projection with horizontal, actual horizontal. So what is this angle? This angle is nothing but theta minus alpha. So we get ux, component of velocity along the incline, as u cos of theta minus alpha. Uy will be u sine of theta minus alpha. Okay. Hence ay. Let's see this diagram very carefully. This is acceleration in downward direction. We have to take their components along and perpendicular to the incline. This angle is alpha, so we can say this angle will be alpha. So perpendicular to incline will be g cos alpha, and here will be g sin alpha. So ax is nothing but minus g sin alpha, and ay is g minus g cos alpha. Okay, these are the two important values of acceleration in y and x directions respectively. What about time of flight? Time of flight is again time in which sy becomes 0. Again, so using this equation, sy is equal to uyt plus half ayt square. We can put the values to get sy as 0 and uy as 1t will be cancelled, so we'll left with uy plus half ayt equal to 0. So time of flight is nothing but 2 uy by ay. Putting the values, we get the expression as 2u sine of theta minus alpha by g cos alpha. Okay, obviously ay will be with minus. So we get these parameters in time of flight. What about maximum height? Maximum height is basically sy when vy becomes 0. Okay, so using the third equation, vy square is equal to uy square plus 2 ay/sy, we can say this is 0. So sy is nothing but minus uy square by 2 ay. Putting their values, we get h, again maximum height from the incline, as u sine theta minus alpha whole square by 2 g cos alpha. That will be the maximum height. Okay. What about range? Range is nothing but range is sx in time equal to time of flight. So use sx is equal to uxt plus half ax t square. Put the values of ux and time period or time of flight in this to get the expression for range. The expression of range is very I should say complex, so you no need to remember, just you should know how you can get those expressions or get those values. Okay, the only concept is you have to take components along and parallel or perpendicular to the incline. Okay, then solve it using by equations in particular direction, you will get all the answers. In the next question, a ball is projected horizontally with a speed v. Find its range on the incline. What happened? There is an incline which makes an angle theta with horizontal, and a ball is thrown with a velocity v horizontally. Horizontally means parallel to the ground, and we have to find how much distance it covers parallel to the incline. Okay, so again, in this case, the velocities along incline and perpendicular to the incline will be this. Let's say this angle is alpha or theta, this will also be theta, so this will be v cos theta, and vertical velocity will be v sin theta. What about accelerations? Acceleration is this g, and take the component of g, and this angle will be theta, so we get g sin theta and g cos theta. Okay, so we have all the parameters, and sy is 0. This is the given term, sy is 0. So we can use we can find time and then range. So time is nothing but 2 sy sy is equal to uyt plus half ayt square. Using this equation, sy equal to 0, so t comes out to be minus 2 uy by ay. Okay, just put the values to find t. 2, what is uy? Is v sin theta. What is ay? Is g cos theta. Okay, so this is the time. This can be written as 2v tan theta by g. Okay, then range. Range is sx, which is uxt plus half ax t square. So we get range is equal to ux is v cos theta into t is 2v tan theta by g plus half ax is g sin theta square. G sin theta is ax into t square. T is 2v tan theta by g whole square. By solving this, we can easily take few things common, as we can take 2 g in the denominator, v square and sin theta. We can take these terms common, and we will left with here 1 and here tan square theta. So 1 plus tan square theta is nothing but sec square theta. So we are getting this expression in terms of range. The next question is, ball is projected normally up. We have to find time height above the plane. Again, the speed u is 10 meter per second. It is given. Angle is 30 degree. Again, take the components. We have uy means perpendicular to the plane 10, ux as 0, ax, again take the component of acceleration. This will be 30 degree, so we get g cos 30 ay and g sin 30 as ax. So ax is g sin 30 means g by 2, ay is minus 5 root 3, which is g cos 30. Okay, so time of flight, t is again time when sy equal to 0. Putting, we get time as minus 2 uy by ay. Put these values to get minus 2 into 10 by 5 root 3 with a minus sign. So we get time as, this will give you 4 by root 3. What about height? height is Sy when Vy equal to 0. Sy when Vy equal to 0. So use the third equation, Vy square is equal to Uy square plus 2Ay Sy. We get Sy as minus Uy square, which is 10 square, by 2Ay, which is minus 5 root 3. So that will give you 100 by 10. 10 by root 3 is the maximum height above the ground, or above the incline. Okay, enjoy.